Alright, these are 9B notes. We're going to be looking at formulas for geometric sequences and series today. Recall that a geometric sequence or series is where you multiply or add by the same number each time. So the first we're going to look at the formula for the rules for a geometric sequence. So the following formula, a sub n equals a sub 1, which is the first term in your sequence, times the ratio, that's your common ratio, what number you're going to multiply or divide by each time, raised to the n minus 1 power. Here's our first example. Write a rule for the nth term of the sequence 512, 128, 32, 8, etc. And then we're going to find the 10th term. Okay, so look at our formula. What do we need? We need the first term, a sub 1. So in this case, a sub 1 is 512. We also need the common ratio. Alright, so what happens? What do you do to 512 to get 128? What do you do to 128 to get 32? What do you do to 32 to get 8? You always want to put the latter term over the previous term. And it doesn't have to be the first two terms. It can be any consecutive terms. So since like I said, keep it easier on myself, I'm going to look at 8 over 32. Well, 8 over 32 reduces to 1/4. So that means my common ratio is 1/4. So now all we got to do is plug it into our formula. So let's do that. We're going to plug in, instead of A1, we're going to put in 512. Instead of our ratio, we're going to put in 1/4. Notice I'm putting parentheses around that ratio. And it's going to be raised to the n minus 1 power. So there's our formula, our general formula. Now we cannot multiply 512. We can't take 1/4 of 512. All right, because you got to raise to the exponent first. So that's as simplified as we can get that expression, or that equation. All right, now let's find the nth term. That means n is equal to 10. So in place of my 10, or in place of my n, I'm going to plug in 10. All right, so A1 here again is equal to 512. Our ratio is 1/4. And it's going to be raised to the n minus 1 power. So n is 10, because I'm looking for the 10th term. All right, let's evaluate that expression. So that's going to equal to, leave it as a fraction, it's going to equal to 1 over 512. Don't make it a decimal, because like I said, that'll have to be a rounded answer. So leave it as a fraction. All right, there's the first one. So here, just depending on what information we're given, we're going to look at a few different problems with given different pieces of information. So here's number 2. One term of a geometric sequence, the third term is negative 18. The common ratio is 3. We want to write a rule for the nth term. Okay, so they tell us our ratio. Our ratio is 3. But this time we don't have the first term. So we're going to have to work backwards and find the first term. Alright, we do know the third term, however. So let's plug into our formula what we know. We're going to solve for a sub 1 this time. So instead of a sub n, we're going to plug in negative 18. A sub 1 is what we're looking for. Alright, we know our common ratio is 3. And we know our n is 3, because it's the third term. Alright, let's solve for a sub 1. So this is going to give us negative 18 is equal to, all right, let's see, 3 minus 1 is 2, so 3 squared is 9, a sub 1. So if we divide, we're going to get that a sub 1 is equal to negative 2. So our first term is negative 2. All right, so now we have everything that we need to find our general rule. So let's pull up our formulas. So a sub n is equal to a sub 1, which is our negative 2, times our common ratio, 3, to the n minus 1 power. So there's our rule. Now here again, we cannot multiply negative 2 times 3. So that's that's as simple as we can get that general rule. All right, you need to add a problem. Add this problem to your notes. So take a moment, pause the video if you need to. So we're going to write the general rule for the geometric sequence when the third term is 8 and the fifth term is 2. Okay, so here, we don't have either piece of information that I need. I don't have the first term and I don't have the common ratio. Let's find the common ratio first. All right, since it's a ratio, we're dividing. And we always want to look at a latter term before a previous term. So the first thing you want to do, all right, we're going to divide 2 by 8. 2 divided by 8. Now here, because there's 5 minus 3 is 2, we're going to be taking the square root of this. So to find the ratio, it's going to be the square root of 2/8, which is the square root of 1/4, which is 1/2. All right, so our common ratio is 1/2. So if the difference between our numbers or terms had been 3, then we would take in a cube root. But we'd still divide. Like I said, we divide a latter term by a previous term, and then like I said, whether it's the square root, cube root, fourth root, it's the difference between our n's. In this case, 5 minus 3 is 2. That's why I took a square root. If you have a question about that, please ask, because this is probably one of the most challenging problems, is this kind of situation. Okay, so now we need to work backwards and find the first term. All right, now here again, I can use either one of these terms. I can use the third term being 8 or the fifth term being 2. It doesn't matter which one I use to find the first term. I'm just going to use that the third term is 8 in my calculation. All right, so let's substitute in. So I'm going to substitute 8 in for the nth term here, my third term. My ratio is 1/2. And my n is 3. Okay, so let's solve for this. So what do I have? I have 8 is equal to my first term times 1/2 squared. So 1/2 squared is 1/4. So I'm just going to put this in the front because you usually put coefficients in the front. All right, so to solve for a1, we're going to multiply by 4. So that means my first term is 32. Okay, so let's make our rule. Now we have everything we need. We know my first term is 32, and my ratio is 1/2. So let's make our rule. So this is going to be equal to my first term, which is 32, times my ratio, 1/2, to the n minus 1 power. Okay, there's your rule. And we can use that to find any term we want in our sequence. So that's probably one of every different kind that you're going to see, given the different pieces of information, or lack of pieces of information. Now let's look at the sum formulas. We have two sum formulas. The first one we're going to look at is when we have a finite geometric series. We're going to find the sum of a finite geometric series. All right, notice, like I said, you notice it's geometric because it looks like if you take away the summation, it looks like the general rule. Our a sub 1 times our ratio, in this case I minus 1 instead of n minus 1, power. All right, so look at our formula. We want to find the sum of the first 13 terms. So here in this case, our n is 13 because it goes from 1 to 13. Here again, be careful. If this started at 0 and went to 13, we'd have n equals 14. All right, we need the first term. All right, so that means we're going to plug 1 into our rule here. So once we plug 1 into our rule, we're going to get 3 times 4 to the 1 minus 1, which is 3 times 4 to the 0 power. Well, 4 to the 0 power is 1, so that means our first term is 3. Our common ratio, all right, it's whatever's raised to the power, so our common ratio is going to be that 4. So our common ratio is 4. All right, so now we have all the pieces of information that we need. Let's plug into our formula. So the sum of the first 13 terms is going to be our a sub 1, which is 3, times 1 minus r, which is our 4, to the nth power, which is 13, all over 1 minus r, which is 4. All right, be really careful when you put that in the calculator. You might want to do it in pieces, use the templates, but you should be getting this large number as your answer. So 67,108,863. All right, I also will show you some calculator tricks when we get to class. All right, let's try another one. All right, here again. All right, so here we have a, I think I skipped one. Hold on. There we go. Went one page too far. All right, here's another example. All right, find the sum of the geometric series. Goes from 1 to 11 of 7 times negative 5 to the I minus 1. All right, here again, n starts at 1, goes to 11, so n is 11. Our ratio is negative 5. The first term, plug in 1 for I. So you're going to get 7 times negative 5 to the 1 minus 1, which is 7 times negative 5 to the 0 power, which is 7. All right, we need to be really careful because our ratio is negative here. So be really careful when you put this in. I'm going to put parentheses. Anytime I plug in something with a negative, I'm going to put parentheses around it. All right, so we're going to plug in all the information that we have now into our formula. So notice how I put parentheses around that negative 5. Because if you're raising a negative 5 to an even power, that's going to make it positive. You do not want to change that sign until after you raise it to a power. Remember, order of operations always holds true. All right, here again, careful when you put this in the calculator. But here's your final answer. So 56,966,147 is our sum. The sum of the first 11 terms in our series. All right, so here's two examples of finite series. So they have a beginning and an end. Doesn't always have to start at 1, so be cautious of that. Let's look at a couple of examples when we have an infinite series. All right, so here's the formula for a geometric infinite series. Notice there's a restriction. The absolute value of our ratio r has to be less than 1 in order for this formula to work. If the absolute value of r is greater than or equal to 1, so if our ratio is greater than or equal to 1, then the series has no sum. The sum does not exist. So our series has no sum. Alright, so make sure you check that restriction before you start using the formula. Because the formula lets you use it, but you won't be using it correctly. Alright, so here, what do we need? We need the first term, and we need the ratio. Okay, so our first term, well, that's an easy one. Our first term is 1. Alright, how about the ratio? We've got negative 3 fourths divided by 1. So that means our ratio is going to be negative 3 fourths. Alright, let's check our condition. Absolute value of negative 3 fourths is positive 3 fourths, and that's less than 1. So that means we can continue with our formula. Alright, so we're going to find the sum of this infinite series. So we need the first term, which in this case is 1. Plug that into our formula. And then it's 1 minus our ratio, where our ratio is negative 3 fourths. So when we start simplifying this, we're going to get 1 over 7 fourths. Flip and multiply. So our answer is going to be 4/7. So the sum of this infinite series is 4/7. This is kind of the idea of limits you'll talk about next year. All right, so we're going to approach a value. Even though we're going, I was going to approach kind of like the idea of an asymptote. We're never going to quite, we're not going to get past that value of 4/7. All right, let's look at another one. All right, so here, we've got another infinite geometric series here. So the first term, well, our first term is 4/15. All right, let's look at the ratio. So we got 4/9 over 4/15. Well, let's reduce that. So that's going to simplify to 4/9 times 15 fourths, which is equal to 15/9. Well, the absolute value of that is still 15/9, and that's greater than 1. So that means that this infinite series sum does not exist, or it has no sum. So make sure you check that condition, because you can't use the formula if the ratio is larger than 1. All right, one last example. All right, so notice a different format here. It's in summation notation. All right, still need the same pieces of information though. All right, so our ratio is 1/5. So that's okay, because the absolute value of 1/5 is 1/5, and that's less than 1, so we can continue. So now we need the first term. All right, let's find the first term. And you might be noticing a pattern, a way of recognizing without having to plug in the values. All right, so we plug in 1 for n. So we're going to end up with, plug in 1 in for n. Simplify, we're going to get 8 times 1/5 to the 0 power, which is 1. So that means our first term is 8. All right, let's plug into our formula. So our first term is 8 over 1 minus our ratio, 1/5. All right, do the algebra. We're going to have 8 over 4/5. Flip and multiply. So we're going to have 8 times 5 fourths, which simplifies to 10. So that means the sum of this infinite geometric series is 10. All right, here again, you'll be given these formulas on the SOL. So you just got to make sure you know how to use them. Plugging and chugging. All right, have a good day.